For review question 2, solve the following simultaneous inequality. So now I have fractions involved in this inequality. Same thing, I will have to break this inequality up to two different parts. One part is this, and the second part will be this one. All right, so for the first part, it's x over 2 smaller or equals to 3x plus 2 over 5. Okay, and for the second part, it will be 3x plus 2 over 5, smaller or equals to x plus 6 over 4. So from here, I will solve the inequality individually first before I combine them. All right, so for the first part, whenever I have fractions involved in inequalities, keep in mind, do not cross multiply them, but rather you change the denominator to the same one, and we will work on the numerator itself. All right, so for the first portion over here, I have denominator of 2 and denominator of 5. Common denominator between these two will be 10. All right, so for the first one, I have to multiply it by 5. And for the second one, I will have to multiply it by 2. All right, now that my denominator is the same, I can cancel them away, and I will just focus and work on my numerator itself. So I have 5x smaller or equals to, I'll rainbow this in to become 6x plus 4. And from here, I will shift x to one side and numbers on the other side. 5x will stay, 6x will come over to become minus 6x, smaller or equals to 4, and minus x smaller or equals to 4. And finally, when I want to pop the negative over from my left to my right, I will have to flip my inequality sign. So I have x is greater or equals to minus 4. And I'm done with the first portion over here. Now moving on to the second part. Same thing. I will have to make my denominator the same first. And for the first fraction, I have 5 as the denominator. Second one, I have 4 as the denominator. So for this set, the common denominator over here will be 20. And for the first one, I will have to multiply it by 4. And for the second one, I'll multiply it by 5. Okay, same thing. Denominator is the same. I can cancel them away and just work on my numerator itself. I will expand it in. I get 12x plus 8, smaller or equals to 5x plus 30. All right, from here, I will shift my algebra to one side. 12x will stay. 5x will come over to become minus 5x. Smaller or equals to 30 will stay on my right-hand side. And positive 8 will come over to become minus 8. Okay, and 12x minus 5x, I get 7x. Smaller or equals to 22. X smaller or equals to 22 over 7. I can leave it in improper fraction, or I can leave it in mixed numbers as well, which is x is smaller or equals to 3 whole 1 over 7. Now, looking back at the question, they asked us to solve the following simultaneous inequality. I can also represent it in a simple number line. Okay, with 0 in the middle. Right-hand side are all my bigger numbers, 1, 2, 3, and 4. And all my negative numbers will be on my left-hand side. Okay, so I'll draw this part first, which is x is greater or equals to minus 4, meaning I will have to color my circle over here. Greater than, I will go towards my right side. And where do I stop? I will stop over at 3 whole 1 over 7, which is somewhere around between 3 and 4. So somewhere around here. Okay, smaller or equals to, same thing, I will have to color my circle and I will just join it up like this. Okay, so finally, my values that satisfy this inequality will be between minus 4 to 3 whole 1 over 7. And this is my answer.